Upper and lower bounds. This is all to do with the way we do rounding. So here we've got a situation where we've told that the weight of the potatoes to the nearest kilogram is 25 grams. Now typically with these questions what they're now going to ask us is what is the minimum possible weight the potatoes could have been or the maximum possible weight. So the lower bound is your minimum, your upper bound is your maximum. Now if we've rounded these to the nearest kilogram, if we put the 25 grams in the middle, so we're working to kilograms, so that's going up in ones and going down in ones, like this. If we think about what we would have done when we're rounding, anything bigger than 24.5 would round up to the 25. Similarly on this side, anything smaller than 25.5 would have rounded down to the 25. So here are our bounds of how big or small the weight of the actual potatoes could have been based on the level of rounding that's been done. So this here, 24.5, is our lower bound, and this here is our upper bound. Now, some of you might be looking at that and saying, well, but if it was 25.5, you would round it to 26, and you would be correct. However, the number that's immediately before that would be 25.4999 going on forever. You can't realistically put that into a calculator. And so if we were to round this to one decimal place, this rounds back to 25.5. So if you're doing normal ordinary rounding, 25.5 very definitely does round to 26. But when we're talking about upper and lower bounds, it's about the practicality of things. And so the upper bound technically is this, but practically for actually putting it into the calculator and working with it, we're going to use this. So that's upper and lower bounds. I'm going to do another example just to show something slightly different. So with this example, you can see we're working with the length of a field, and it's been given accurate to the nearest 5 meters, and the actual measurement is 145. So I'm going to draw my line again, and in the middle I'm going to put 145. Now this time I'm going up and down in 5s and not 1s. So that would be 150 here and 140 there. And so our halfway mark here is going to be 142.5, and our halfway mark here is 147.5. So this is our lower bound, and this is our upper bound. Okay, so pay attention to the nearest how many. So if it's a whole number or a 1 of some sort, then just go up 1 and down 1. But if it says to the nearest 5 or 10 or something else, then you need to adjust how much you jump up and down for the ends of these scales. So now we're going to look at what happens when we take these and put them into formulas, because that's another common question. So we're going to start by looking at questions to do with formulas where we're either multiplying or adding the parts of the formula. So they might ask us for either the maximum area or the minimum area. Again, this transfers to the upper bound of the area or the lower bound. Max, min, upper, lower bounds, they're interchangeable words here. Okay, So let's say that we wanted to do the maximum. So let's say first of all that our width is 4 to the nearest one and our length is 6. So that means that our upper bound of the width would be 4.5 and our lower bound will be 3.5, and our upper bound for our length will be 6.5 and our lower bound will be 5.5. So if I want the maximum area, I need to multiply the two biggest numbers together. So we're going to use both of the upper bounds for that. So the maximum area would be what you get when you do 4.5 times 6.5. Now I'm not going to worry about working out that answer. The point is that we need both of the upper bounds to get the maximum. If we want the minimum, i.e. the smallest possible area, therefore we're going to use the two smallest possible answers here. So it's going to be 3.5 times 5.5. If we think about perimeter, whether it's a rectangle or a triangle or whatever it is, it's basically about adding all the different parts together. So we're going to pretend it's a rectangle and we're going to use the same figures that we've got up here. So a width of 4 and a length of 6. So again, if we want the maximum perimeter, then we want the biggest width and the biggest length all the way around. So we're going to have two lots of the 4.5 and add on to that two lots of the 6.5 to get our maximum. And then if we want our minimum, we'll use two lots of the 3.5 and add on two lots of the 5.5. Now, if you don't want to multiply, you can do 4.5 plus 4.5 plus 6.5 plus 6.5 and so on for this, but you get the drift there. Okay, so if you've got a formula and it involves adding and multiplying, then you're going to want the maximums. Now we're going to look at what happens when there's maybe takeaway or division involved. So, common formula that you might come across where you've got to do some takeaway is the range, which is the highest minus the lowest. Okay, so let's say that the two figures, the highest and the lowest figure in this case, are 10 and 5. Now, the upper bound, so these are accurate to the nearest one we're talking about here, so the upper bound would be 10.5 and the lower bound of this would be 9.5, and here the upper bound will be 5.5 and the lower bound will be 4.5. Now let's talk about getting the maximum range first of all. So we want the biggest possible answer. So that means we want the biggest possible difference between these two numbers. So that means we want the maximum of the highest and the minimum of the lowest. So we're going to need the 10.5, but we're going to take away the 4.5 because that will give us the biggest ultimate answer, which in this case, might as well do it, is 6. If I do any other combination, it's going to be smaller. So 9.5 take away 4.5 is only 5. 10.5 take away 5.5 is 5. We're not going to get a bigger number other than this way. So we've used the upper bound here and the lower bound here to get the maximum. So if we want the minimum, we're going to reverse that. So we want the smallest possible difference. So we're going to use the smallest for the first number, but the biggest for the second number. And if we take those away, we get 4. So if you check it out for yourself, but no other combination of taking them away is going to give you a smaller number. 10.5 take away 5.5 is 5. 10.5 take away 4.5 is 6. Bigger. Yeah, and we want the minimum. So another common formula that you might come across is speed, which is distance divided by time. So we're going to use the same two numbers again. So this is going to be our distance and this is going to be our time, just to save time here. So this one might need a little bit more thinking through, but if we want the maximum speed, we're going to get that by taking the maximum distance, 10.5 in this case, and dividing it by the minimum time, 4.5. Just stop and think about it. Those numbers are a bit awkward to think about it, but if we just think about 10 and what we can divide it by. If I divide it by 5, I only get 2. Whereas if I divide it by 2, I get 5. So to get the bigger answer, I need to divide by the smaller number. And of course, if we want to do the minimum speed, we're going to reverse the process. So on the top, we're going to have the minimum, which would be 9.5. And on the bottom, we're going to have the maximum, like so.